In this short video, we're going to introduce writing Scala programming code in your Spark notebook. Spark notebooks let you mix plain prose with programming code, and in this project, we'll be using the Scala language to write that code. The key idea that we want to focus on is modeling data. We're going to be working with data that is saved in files. We also want to think then about how do we represent that data when we're working with it in a programming language like Scala. And just as a reminder, the data that we're going to work on in our first exercise is data related to tribute payments to the city of Athens. So what we want to model are those payment records. And to review, as you will recall from your homework and class discussion, every payment record has about 7 items of information that we might want to observe and record: an identifier for the record, a reference to the passage of text where the record comes from, the name of the city-state as it's recorded in the inscription, but also a unique identifier for the city-state in case the text is fragmentary or we want to be able to identify it uniquely, the year number, sequence of this record within the year, and of course the quantity, the amount of obols in Athenian currency system that were paid. So we'll be working with data that's stored in a comma-separated value file, a CSV file that has simple structure of columns identified by commas, and then one record with those 7 columns of data in each line. So a single payment record might look like this. And it might be a payment of 100 obols by place number 2. Place number 2 might be actually labeled as farbelioi on the text, and that might be the second payment item in year 1 of the payment records. So how are we going to model that in Scala? Well, as background, in Scala, as in many programming languages, values belong to a class. And so the first thing we're going to learn about Scala is how to define values using the val keyword. Let's just open up a Scala notebook. I've created a notebook here and have a blank cell. This green outlined cell can be either a code block, or it can be a block where you just write plain prose using markdown, this sort of simple text-only notation. But we're going to write some Scala code right now. And first I'm going to create a value. Let's just call it message. And I'm going to store in that named value message the following string. What are the Athenian tribute? Okay, tribute lists. Now I can execute the code in that block by hitting this Go button. And you'll see that the Spark notebook tells me this is a string class of object, and it has this following value. So every value belongs to a class, and in your Spark notebook you will be able to see displayed for you what is the class of each object. Now, depending on the class of the object, different functions are available, and functions can create a new value, potentially even a new type of value, and we apply functions that are appropriate for each class of object using a dot notation. Let's say, for example, that we want to know how long this string is. Well, message is the string object I'm working with, but strings have a function called size that will count the number of characters in the string for us. So now if I run the code in this block, I can see that the result is an integer type object, 36. So the size function, when you apply it to a string, creates an integer object, and I can find out that the length of that string is 36 characters long. Or to do a slightly different kind of function, there's a function called toUpperCase. When you apply it to a string object, it turns all of the characters into uppercase versions, so you can get a screaming loud version of your string object with the toUpperCase method. So Scala comes with built-in classes such as strings or integers, as we just saw. But in addition to that, you can define your own classes. So let's just take a really stripped-down version of the kind of data we're working with and create a very simple class for payment records. Instead of 7 items of information, we'll, for this example, just use 3 simple categories. We'll define the class using this pair of reserved words, case, class, and then we'll name it. So I'm just naming it payment. And in parentheses, I'm specifying that a payment class of object has three components. It has a label, a year, and obols. And I'm telling you what class each of the components belongs to. So the label is a string, the year number is an integer, the number of obols paid is an integer. So let's look at that in Scala Notebook. I'll start a new cell down here, and it's another code cell. So I'll just make some, I'll just continue right here to create a new class called payment, and it's going to have a label that will be a string. Notice as I'm working in the Spark notebooks that it's going to use color to help you figure out the syntax of what you're doing. Those reserved words, those special words are in bright green, for example. I wanted to include the year number. That'll be an integer object. And of course, I want to include the number of obols paid, so that's another integer. And now the kind of luminescent green here is helping me match parentheses, so I've got those matched up right. That looks good. Let's execute that block of code. And it tells me I defined a class payment, which is what I wanted to do. Very nice. But now I want to create and use objects that belong to that class. So I'll be creating a value. I'll use the val keyword. But this time, I'll specify that the value I'm creating is a payment type of value. And I'll supply for each of the three components, we said that they were in sequence, a labeling string, a year number, and a number of obols. I'll simply supply those in parentheses like that. So let's try that out. I'm going to create a record for 1 year's payment. It's going to be a payment object. And let's say that it's Farbeoi is the name of the payment. It's year 1, and they're going to pay 100 obols. Now, let's execute that block one more time. And we find out that we have a record that's now a payment type object. So it belongs to the type we defined. And there's what its value looks like. I can work with now these payment type objects and can refer to particular components by name using the name that I defined when I defined the class. So record.obols, for example, is an integer value of 100, whereas record.label is a string value of the label that I gave. The last thing I want to mention very briefly is that you can also put together collections of objects, such as lists, and there may be particular types of functions. There are particular types of functions that apply to lists. So let's imagine the case, for example, if we wanted to have a list of obol payments, one payment of 100 and another payment of 100 and a payment of 200. Run that block of code and, oops, sorry, syntax error. Thank you for the hint to check the parentheses. That should be better. I've got a list of a block of 3 things. Let's see if I can do this. List obols sum. Sorry, I forgot to tell it it's a list. There we go. I'll get it right. This is a list of 3 integers. Let's just verify that by running it first on its own. Good. It's a list of integers. And one of the functions I can apply to that is called sum. So I can see that adding up all those gives me an integer value of 400. This is just a brief illustration of the kinds of things that are possible with generic programming in Scala. In our next video, we're going to look at how to do some specific things focused on Athenian tribute lists.